Without one chemical, your pool loses 90% of its chlorine by lunchtime. Sunlight just rips it apart. Today, we're talking about the molecule that solved that problem and the new problems it created along the way. Here's the science. Hypochlorous acid, HOCl, is your pool's real sanitizer, but ultraviolet light from the sun breaks it apart into hydrochloric acid and oxygen. That reaction is irreversible. Once the chlorine is photolized, it's gone for good. How fast does this happen? Research shows that in direct sunlight, a pool with no stabilizer loses 75 to 90% of its free chlorine in just 2 to 3 hours. Start at 4 ppm in the morning, and you're below 1 ppm by lunch. Before the late 1950s, the only answer was brute force. Add more chlorine more often. Outdoor commercial pools needed near constant chemical feeds just to keep residuals up during operating hours. Expensive, exhausting, and often not enough. Then in the late 1950s, Monsanto Chemical Company developed 2 stabilized chlorine compounds, trichloroisocyanuric acid, Trichlor, and sodium dichloroisocyanurate, Dichlor. These products were revolutionary because they combined a chlorine donor and a UV stabilizer in a single molecule. Each product has distinct characteristics. Trichlor has about 90% available chlorine, is highly acidic at pH 2.8, and adds roughly 6 ppm CYA for every 10 ppm chlorine. Dichlor is near neutral pH, dissolves fast, and adds about 9 ppm CYA per 10 ppm chlorine. The mechanism is elegant. Cyanuric acid forms a reversible bond with hypochlorous acid. While chlorine is bound to CYA, UV light can't break it down. But here's the key word, reversible. As free chlorine gets consumed, the equilibrium shifts and more HOCl is released from the CYA reservoir. Trichlor tablets became the dominant form of residential pool chlorination by the 1970s. Slow dissolving tablets in a floating feeder, low maintenance, consistent chlorine, built-in UV protection. It seemed like the perfect solution, but here's the catch. Cyanuric acid does not degrade. It doesn't evaporate. Shock doesn't destroy it. Sunlight doesn't break it down. Nothing in your pool consumes it. Every time you add trichlor or dichlor, the CYA stays behind, and it accumulates relentlessly. A typical residential pool adds 3 to 5 ppm of CYA per week from trichlor. Over a single season, CYA can climb from 30 to well over 100 ppm. Over multiple years without draining, 200 to 300 ppm is not uncommon. The only way CYA leaves a pool is through physical removal of water, draining, splash out, backwashing, or rainwater dilution. That's it. There's no chemical shortcut. This makes prevention, like monitoring CYA and supplementing with unstabilized chlorine, far easier than correction. Here's where it gets interesting. For decades, the industry said maintain 2 to 4 ppm free chlorine, period. But Anderson's 1965 research showed that CYA dramatically reduces chlorine's killing power. At high CYA, the DPD test shows chlorine is there, but it's not effective. The real measure of sanitizing power is the ratio of free chlorine to CYA. Double the CYA with the same FC, and you roughly have your disinfecting power. The widely cited guideline, maintain FC at minimum 7.5% of your CYA level. CYA at 40, keep FC at least 3 ppm. Want to check your own FC to CYA ratio? We built a free CYA calculator at PoolDial.com. Plug in your numbers and see exactly where you stand. Link in the description. CYA creates another problem most operators overlook. The standard total alkalinity test picks up cyanuric alkalinity. Yeah, which doesn't actually buffer pH. So your TA reading is inflated. The fix: subtract 1/3 of your CYA reading from total alkalinity to get your true carbonate alkalinity. One more thing. CYA exists to solve UV degradation. Indoor pools don't have that problem. Artificial lighting doesn't produce the UV wavelengths that destroy chlorine. Using Trichlor indoors gives you all the CYA downsides with zero UV benefit. Use unstabilized chlorine for indoor pools. Where should CYA be? The CDC recommends a maximum of just 15 ppm IP for public pools. They're prioritizing fast disinfection. The industry standard for residential outdoor pools is 30 to 50 ppm. That's the sweet spot where you get UV protection without crippling your chlorine. When CYA gets too high, here's the math. Gallons to drain equals pool volume times 1 minus target CYA divided by current CYA. A 20,000 gallon pool at 150 ppm trying to reach 50, you're draining over 13,000 gallons. That's 2/3 of the pool. For the CPO exam, know the basics: what CYA does, why it matters outdoors, the recommended ranges, and the accumulation problem. For real-world practice, go deeper, understand the FC-CYA ratio, correct your alkalinity readings, and monitor CYA levels all season long. That's cyanuric acid, the chemical that made modern outdoor pool care possible, and the one that punishes you if you don't respect its limits. This was part 3 of our 5-part history of pool chemistry series. Subscribe so you don't miss part 4, where we cover the research that proved everyone's water balance calculations were wrong.